Hi guys, so welcome back to my channel. So now we're going to continue our discussion on integrals yielding inverse trigonometric functions. So by solving examples 1 to 4. So let us recall first the formulas we're going to use. So we have the integral of du over square root of a squared minus u squared equal to arcsine of u over a plus c. The second one is integral of du over a squared plus u squared equal to 1 over a times the arctangent of u over a plus c. And the third one is integral of du over u times the square root of u squared minus a squared equal to 1 over a times the arcsec at u over a plus c, where a is any constant and u stands for any function differentiable to x. So, example number 1. So, evaluate the integral of dx over square root of 9 minus x squared. So, the first thing to do is to determine the value of a and value of u. So, we have a squared is equal to 9. Getting the square root of both sides, so we have a is equal to 3. The next, u squared. So u squared is equal to x squared, where we have u is equal to x. Then differentiate, so du is equal to dx. So next, by substitution, so we have integral of dx, so that is du over square root of, so a squared is equal to 9. So we have a squared minus x squared, so that is u squared. So to integrate, so we're going to use the first formula, so which is the arcsin. So the integral of du over square root of a squared minus u squared is equal to arcsin of u over a plus c. Then substitute the value of u and the value of a. So the answer is arcsin of x over 3 plus c. Example number 2. So evaluate the integral of dx over 25 plus x squared. So first, to identify the value of u and the value of a. So a squared is equal to 25. So getting the square root of both sides, so a is equal to 5. And u squared is equal to x squared. So getting the square root of both sides, u is equal to x. Differentiate, so du is equal to dx. By substitution, so we have integral of dx is equal to du over 25. So replaced by a squared plus x squared is equal to u squared. So to evaluate the integral, so we're going to use the second formula, which is the arctan. So the integral of du over a squared plus u squared is equal to 1 over a times the arctangent of u over a plus c. Then substitute the value of a and the value of u. So we have 1 over 5 times the arctangent of u, so that is x over 5 plus c. Example number 3. So evaluate the integral of dx over x times square root of x squared minus 100. So first, identify the value of u and the value of a. So we have a squared, so that is equal to 100. Getting the square root of both sides, so a is equal to 10. Then u squared is equal to x squared. Getting the square root of both sides, so u is equal to x. Differentiate, so du is equal to dx. Then we have integral of dx, that is du, over x, so x is u, times the square root of x squared, so that is u squared minus 100, so that is a squared. So to integrate, so we're going to use the third formula, which is the arcsec. So integral of du over u times the square root of u squared minus a squared is equal to 1 over a times the arcsec of u over a plus c. Then substitute the value of a and u. So we have 1 over 10 times arcsec x over 10 plus c. Evaluate the integral of x plus 3 over square root of 1 minus x squared dx. Now, as we observe, so we cannot use directly any of the three formulas shown to evaluate the given integral. So the best thing to do, so to evaluate the given integral is to stop the discussion. Siyempre, joke lang. No? So, tawa ka naman. Masyado kang seryoso. No, pag di ka tumawa, babagsak ka sa calculus. So, to evaluate, so we should rewrite the integral. So, in this case, so we will decompose the fraction. So, decomposition of fraction means splitting. No? So, splitting the fraction into smaller fractions. So, like in this example, so we have integral of, so x over square root of 1 minus x squared plus 3 over 1 minus x squared dx. So next is to apply sum rule and apply constant multiple rule. So we have integral of x over square root of 1 minus x squared dx plus 3 times integral of dx over square root of 1 minus x squared. So we have two integrals. So the first integral can be evaluated using substitution method. So let's say we have W. So W is equal to 1 minus x squared. Differentiate, so we have dw so equal to derivative of 1, 0, derivative of negative x squared, so negative 2x dx. No? So we have x dx at the numerator of the first integral. So let's divide by negative 2. So cancel. So we have negative dw over 2. So equal to x dx. Then for our second integral, so we have integral of dx over square root of 1 minus x squared. So identify the value of a and the value of u. So a squared is equal to 1. So a is equal to 1. U squared is equal to x squared. So square root of both sides, u is equal to x. Differentiate. So du is equal to dx. Then substitute. So we have integral of x dx. So negative dw over 2 over square root of w plus 3 times integral of dx. So that is du over square root of a squared minus u squared. Then we have applying constant multiple rule. So negative 1/2 times integral of w raised to negative 1/2 dw plus 3 times integral of du over square root of a squared minus u squared. So integrate. So we have negative 1/2 integral of w raised to negative 1/2 dw. So we're going to use power rule. So w raised to 1/2 plus 1 over negative 1/2 plus 1 plus 3. So integral of du over square root of a squared minus u squared. So that is arcsine. So 3 times arcsine of u over a plus c. Simplify. So negative 1/2 times w raised to 1/2 over 1/2 plus 3 arcsine u over a plus c. So cancel the 1/2. So we have negative square root of w. So w is 1 minus x squared plus 3 times arcsine of u is x over a 1. So arcsine x plus c. So the answer is negative square root of 1 minus x squared plus 3 times arcsine x plus c.